Brian can take it away.
Okay, sounds great. I'm Brian Eilber. I'm a cloud solutions architect with INetU, which basically means my responsibility is working with our incoming customers. As a managed service provider, we want to be able to provide not just hosting solutions or just hardware or anything like that. We want to be able to provide a complete solution. So I'm the kind of guy that goes on the phone when, say, you need a hosting platform for your Magento or your e-commerce site. I'll be the one asking the questions, trying to get a little bit more insight about what you're selling, what you're trying to accomplish, and be able to design a complete solution that will meet all of your needs. And I'm pretty much one of the guys who'll be working through the entire process if that's the case. I'll jump right in my bio here, but I'm titled here, Optimizing Infrastructure for Magento Apps, and this is truly going to be an adventure into the world of best practices. So that's me. I'm Brian.
Yeah, Brian.
As mentioned, I'm a cloud solutions architect. I've been in IT for over 13 years now, many different industries, worked with many different verticals. Currently, as a managed service provider, I've been with INetU for the last 6 years. Been through many different roles. Started as a Windows guy, moved to the Unix team, became a team lead there, moved into engineering, and then here into sales and traveling around with Janine. So I've been all over the company so far, but another thing I really like pointing out is my personal bits here. My spare time, I love spending time with my family, working my own little technical pet projects, whether it's trying to make some solution that I found on the internet that somebody said is going to be the next big thing actually work, or brewing beer, for instance, and drinking it as well. No need to let it go to waste. Do some video game streaming and some things on YouTube. And I also noticed on the profile for the event here today, Janine put in a little note that we has an inside joke about me drinking with vice presidents of Red Hat. So I felt obligated to actually show the picture of me, a couple of the people from Red Hat, and Marco Bill Peter, who's the VP of Customer Engagement from Red Hat. Great guy, a lot of fun to hang out with. He can drink. He can, yeah. It was a long night. So enough about me. Let's talk about the summary for today. I'm going to give a little bit of a summary on INetU in general, kind of talk about what we do, and then we're going to kind of dive into more of the technical aspects of the discussion. So INetU, we've been in business since 1997. We're a managed service provider, so we do hosting, we do managed services on top of our own hosting platforms, and we're really mission critical applications for our customers. Is really we want to be involved. If you have something that can't be down, we want to be the people supporting that. Our support is above and beyond the white glove support that you'd expect to get. So that really ties in well with people with e-commerce sites where you can't have that extended kind of downtime. We want to be working with those kinds of customers to be able to show really what we're made of and basically get everybody through the best solution. This is a list of our data centers, so Allentown, Ashburn, Virginia, Amsterdam, Netherlands, London, Seattle, Washington, and also we do our managed services on top of AWS. I also have some, Janine, do you want to mention some of the people we work with? Because of my nervous situation.
Oh yeah, in terms of Magento clients that we deal with, we host like lipsmackers.com, Spotify, the music store, shop.jetblue, Bavarian Auto Sports, we sell aftermarket products for BMW, Cyberswim, which does miracle shapewear for women. So we've been in the Magento space for a long time, hosting Magento websites and all other different e-commerce websites that have critical nature.
Thank you. And just like before, that's enough about INetU. Let's actually talk about some good stuff here. So let's really look at the definition of infrastructure, because that's an important thing here. And yes, I copied this right from Wikipedia. So of all the words here, I highlighted a few that were really important. So we're looking at the basic physical and organizational structures and facilities for the operation of an enterprise. Those are really the key words that I'm pulling out of here. Your enterprise needs to operate on some form of infrastructure. There's lots of different types of infrastructure out there. I'm going to talk about a couple different options here, some things that we work with most commonly. First one being a public cloud. A public cloud would be like your Amazon Web Services or any other kind of shared hosting provider. We have our own shared hosting services as well. There's some pros and cons associated with this. So, and the pros usually have resilient systems. They're able to sustain any kind of failure. They're designed to be able to come back online and be available. They can be scalable. You can extend horizontally, vertically, depending on what kind of solution you go with. So you're not limited to what your small container or your large environment is on day one. And readily available. Most cloud providers, you can spin up a VM in an instant. Provide a credit card. I have some platform to run my application on. And those are very good pros to have. I mean, it's keeping you to be more versatile. You're not locked in like this environment that prevents you from being agile with your development. The same thing kind of goes to the opposite side, where you're working with other people, so you may be more agile, but noisy neighbor syndrome is something that we refer to when you're working on a shared hosting platform with a customer that's using up like so many resources that you're actually getting starved on your application. Shared infrastructure can have that kind of a problem where there's not enough resources to go around, it's oversubscribed, and it's kind of costly at times of business, especially e-commerce being a big thing, Black Friday, Cyber Monday, usually a pretty big thing in the e-commerce industry. If you have a whole bunch of people running on your equipment, the same equipment as you, there could be contention. You're pure and simple contention, and you don't want to have that in any kind of high-profile business. And then the other option here, obfuscated hardware. You don't know which hardware you're running on in most of these environments. You can get provided certain specs and get an idea of what it is, but you don't know how many VMs are running on your infrastructure. You don't know how many CPUs, for example, any kind of specific resources are going to be available to you, so it's a bit in the dark. You know you're getting a certain amount of resources, but how available are they? So I know that sounds really negative, so I'm not entirely frowning upon the public cloud. Trust me, I got cons for everything. But that's just a good quick overview of just public cloud and from an e-commerce standpoint, specifically Magento. Then there's private cloud, where we're talking more of having dedicated infrastructure, dedicated servers that you're running any kind of virtualization layer on top of to really get better use of those resources to extend across multiple VMs rather than being dedicated to one server role per server. And there's similar pros here. First of all, you're backed by dedicated gear. You know what gear you're using, you know how much resources you have control in that case. It's still scalable up to an extent. You can scale as many VMs and as many resources as you have allocated. If you need more resources, sure, you can purchase more physical hardware to supplement that. And then resilience, it can be built resilient. If you have multiple servers or doing some form of clustering technology for your virtualization layer, you can do something like that. But on the con side, lead time and capital expense. Yes, you can grow your environment beyond what you have today resource-wise, but now that means you got to order servers from Dell. That's going to cost money. You got to wait for them to come in, and your business could be hanging there waiting for those resources to be available to actually perform. Say you've just done some form of growth in your environment, you need to be able to sustain a higher resource load across the environment. That could be a problem. Now usually we're talking private cloud and we're looking larger, more enterprise environments, more than single or dual server environments, but this can apply in almost any situation. And then we have dedicated gear, buying physical servers to have in a physical rack and be hosted upon. So the pros here, it's built for your needs. You're buying a piece of physical hardware that's meant to fill a certain need, whether it's a database server, a Magento server, some kind of caching server, front-end server. You're building it for those needs. And they can be built resilient. You can have a load-balanced web service to provide some form of high availability, clustering on your databases to provide some kind of high availability there. So there is options there. You're not completely out. But on the con side, lead time and capital expense. See, familiar from our previous slide? Same exact concept. We're working with physical hardware. So you're going to have those limitations. When you design your infrastructure, you want to make sure that you're taking some of these pros and cons to account. And then we come to more of a fourth option here, what we would consider a hybrid solution. A little bit of everything. Let's take what we need from each one. Which option is beneficial for which role? So the pros here allows you to look familiar because they're pretty much the exact same things. It's a matter of it can be made scalable, it can be made resilient, depending on where you pick and choose from. If you're working with your application tier on cloud servers, have a database and physical infrastructure, there's a solution there. That's a hybrid solution. You may have different pros and cons across the environment. And then on the other side here, we have a potential for lead time, a potential for capital expense, and the potential, so on and so forth. There's a potential for these kind of cons. You can build around them depending on exactly what your needs are going to be. So, realistically, if you're looking at this, how do you know where you fall on this chart? It depends. Simply enough, it depends what you're trying to accomplish. Which is best? That kind of depends too. So, what I want to do from here, now that we've talked about infrastructure, talked about all those options of having infrastructure hosting, let's talk a little bit more about the stack within Magento. And this applies for almost any other application out there on the web, but this is specific to Magento in this case. So looking at the stack from 1,000 feet, we're working with an application database and some form of caching layer there to increase performance. Very simplistic. Well, what's the application? It does the things. That's your application. It's doing the processing. That's more of your compute tier. What's the database do? Well, it stores the things. Didn't you know? We're keeping information in here, whether it's customer information, product information. If you're in more of a PCI environment, you may have some credit card information there. So these are all things to take into account. And then on the caching, it's remembering the things. Caching is pretty much your go-to to prevent any of these other resources from being hit too often. I hear way too many times where people are running a Magento store and their page load times are slow. Oh, that's to me, that's awful. Like e-commerce site, if you're browsing through an e-commerce site and you click a link, all right, wait for the link to open. Oh, there it goes. Okay, let's click on this. Oh no, that's not the product I wanted. Give me another 5 minutes. Let me go make some tea. You don't want your customer going through that. You want it to be snappy. You want it to be responsive. A lot of that is where your caching is really going to come in and how you're going to design your cache for, as a developer, knowing exactly what to use, where to use it, and which efficiency. So that's just the overview. That's a 1,000-foot view of just looking at Magento. But let's look at it from a customer's perspective. Over here on the left, we have a web application. Somebody using their browser, accessing a storefront. Realistically, their traffic is going to flow kind of through this stack here. Maybe not exactly, depending on your implementation. But if you have some form of full-page caching in the front, the first thing you're going to do is hit this cache. If that cache has the page that they're looking for, send it right back. Fast in-memory caching. Very, very efficient way of doing things. Magento Enterprise has that as a built-in function. The Community Edition, we'll talk about a little more later and some of the options there. If the caching isn't there, well, now we're going to the application. And we're talking application to get either a page rendered, a certain amount of information, checking our opcode cache to see if something has already been built. Do we have this information in another form of cache? If we do, present it up. If not, you're putting some work on your compute tier at this point where, okay, there's going to be some processing that goes on here, possibly some work with the database. You might have to pull some information from there. But now that's going to slow the whole process down. If you're presenting it right from a cache, you're in and out. You're providing that information quick and as fast as you can. If you're going to do any kind of processing there, that's where you kind of want to look at your infrastructure a little more to make sure that you're able to do this portion as fast as you can. Which is why we're going to talk a little more about the good, the bad, and the ugly here. So this is what we call a small business value model. It's very simple. We have one virtual machine for our web tier, and we have one virtual machine for our database tier. So in the essence of Magento, we'd be looking at a MySQL Percona server here, and over here we'd be having an Nginx, Apache, depending on what your services are that you're running. And a firewall and the internet. Very simple environment, rather value-adding, because these can be spec'd rather low. And as the need for business activity increases and you need to have higher resources, we can scale those up. But this brings to the question of high availability. And there's a couple questions that I always talk to people on the phone about, and they apply in any situation, whether it's e-commerce or not. When you're looking at high availability, what kind of things are you protecting against in your infrastructure? Are you protecting against a failure of some kind on your web server? What happens to your store if your web server goes down? Usually there's nothing there. Somebody gets a blank page. If the database goes down, well, nobody's going to get any content. It'll be either a blank page or half image, half like your content's loaded. It all depends on how your application's built. What if the firewall goes down? Well, then everything's gone, and nothing's going to work there at that point. But these are things that you want to build your high availability around. You want to kind of brainstorm and kind of role play these scenarios. Another thing to think about as you're doing this is, are we helping availability? You may be purchasing, I'm going to buy 20 servers. It's going to handle everything. It'll be fine. It'll be set. It's only going to protect the database tier though. The web tier, oh, we only need one of those. Well, now you're not really helping availability. You're putting a whole bunch of resources out there, and if you're using them efficiently, bravo. But what about availability? You want the site to stay up. That's kind of important. Let's build that in mind. And another thing that most people don't really think about is expected failure rates. Their hardware of any kind, technology of any kind is going to fail. There's always a chance of failure. Your firewall, for example, may not fail within the next 20 years. It could possibly stay running. It could fail tomorrow. But the failure rate of, say, like a Cisco firewall, for example, is rather low compared to, say, a Dell server, where there could be a problem on the motherboard, a problem with the power supply, even a problem on the disk, any kind of disk for RAID or anything like that. Are those failures being taken into account of, let's protect against things that are more likely to fail? Now this is really still pretty deep on the infrastructure design portion, but they're all things worth keeping in mind. And all these questions actually can be followed up with, what is acceptable downtime? What are we protecting against? Oh, we're protecting against our web tier failing. Well, what is the acceptable downtime for that? You want to be able to say that when you're looking at a web server failure, that we can lose our web server for 1 hour. That is an amazing piece of information for design, because you can design around, okay, if this fails and we need to have this up within an hour, well, if we keep maybe a second set of gear lying around that we can kind of swap out. And within 1 hour, we can bring the site back up. Great. You've found a solution that doesn't require to have multiple servers on. But that question applies to everything. Are we helping availability with this design, and what's acceptable downtime for this solution? Every time we should be talking about that. And we actually will here too. So we have this environment we showed before, just a single server environment. What happens when that web server just spontaneously combusts in this case? Well, it's gone. You lose your web server. Well, we mentioned before, you won't have users browsing anything at that point. What if the failure is over here? Like, how are we protecting against any kind of failure on this tier? So let's show where we are doing some protection. So here we're looking with our web servers once again, but there's 2 of them this time. 2 database servers here. We have a load balancing device. We're actually moving up here in the world. So what happens in the case of, what are we protecting against here? Well, we're protecting against web server failure, and we have our database servers set up in a way that they are redundant. One could fail, and we could stay online. Well, that's great. Are we actually helping availability? Sure, let's role play it. This web server spontaneously combusts. We still have another web server here serving content, the load balancer, not going to send traffic there, everything's okay. But what happens at the same time, the database server can spontaneously combust? What if that data center just fell into a black hole where both of those existed, but not the other 2? Well, luckily we have this cluster set up. We can sustain that kind of a failure. What's the expected failure rate in this scenario? It's going to be rather low because we have some form of built-in redundancy. But single points of failure still exist. Load balancer, if that goes away, well, there's no traffic being load balanced. That's a single point of failure for our web tier. Well, there's still a firewall. We did mention that before. If you lose your firewall, okay, that's great. Let's get a new one. But what about even uplinks to the internet? What if you lose your total internet connectivity? Your provider goes down. Now we're talking more in the lines of having multiple links out to the internet. And if you're running all this in-house, in your office, and somewhere in your business, it gets a lot more complicated because you need to have all these steps taken. So you can step to something like this, where we have an entire web tier consisting of 5 servers. Ridiculous amount of, this is literally an enterprise model. This is not, I'm going to set up my website tomorrow to sell Beanie Babies. Why did I say Beanie Babies? I'm going to sell, that's fun. I'm going to sell Beanie Babies tomorrow. I'm going to buy all this infrastructure to sell my Beanie Babies. No, not even close. I'm going to be back. Where are we? Go on, a little further. I put too many animations. I'm going to be here. Oh, well, not the exploding server. Let's rephrase that. I'm going to be in this tier. This is where I'm going to be day 1 because I can accept the failure time. I have the staff, this guy, to fix anything that goes wrong. I have certain things accounted for. That may not be everybody's case. All right, let's fast forward back ahead. We're going to time travel, single points of failure, and a really big environment. So we still have a couple points of failure that could come into play. The internet, and everything between the internet and the user. There's so many things there that could fail. But that is a little bit higher of a expected failure rate concern overall because the internet's pretty sustained. There's a lot of different routes across the internet. If you have multiple links coming in, you're usually in a pretty good place to at least get your traffic to your web application. Everything else, we have redundant firewalls, redundant load balancers. Day 1, overkill. But you can at least see what, this is the Cadillac. This is what we're showing. The other one I was showing before was more of like the Pinto. I mean, it wasn't, not very shiny, no bells and whistles, but it functioned really well, sort of. This is more of our Cadillac of everything. Yes, we're covering for a lot of things. Do you need this tomorrow? I don't think anybody needs this explicitly tomorrow, but maybe you do. It's all about looking into what your needs are. And that's kind of what we're going to cover a little bit later on too, after we talk about the payment card industry. So PCI, I'm going to put a little warning up first. There's some fact and opinion coming up here. My opinion on PCI is it worth the risk of handling cardholder data? When there's so many vendors out there, so many payment processors out there that can handle that for you. As far as PCI is concerned, yes, you can take all the steps, through all 12 steps of PCI, have everything done, have auditors and QSAs as your best friends, everything hunky-dory. But there's still that risk there. If you holding that cardholder data, it exposes you to whatever threats are out there. If somebody wants to get cardholder data, they're going to try the damnedest to get it. So PCI compliance may not be needed if you're working with, if you're not handling that cardholder data. If you're going to like authorize.net or someone else out there, sending them all your transactions, great. You're not holding this cardholder data. But their PCI compliance can still be achieved at least that level of PCI compliance. If you're not in scope for PCI compliant, congratulations, you're compliant. But if you're handling any cardholder data, there's things that you need to really think about. And even security as a whole, here's a couple options here that I'm going to talk a little bit about. I'm going to briefly over these because I could probably spend a half hour just talking about web application firewalls in general. But best interest-wise, first thing, every environment should have some sort of firewall in front. You want to be able to protect your content, protect your servers, protect your users' data if you're storing them. The firewall is literally going to be a device that's blocking all traffic except for what you consider acceptable. Definitely the first thing we'd recommend. Network segmentation, being able to separate your web tier from your database tier across different network segments. Let them directly talk to each other. Open up traffic ports in order for them to talk. If your web tier only needs to talk to the database server on database ports, only open that. There's no need to have SSH, RDP, IRC, anything like that open between both servers. It's a bit unnecessary. Allow only what you need to allow. System hardening. Only install the servers we need to have installed. Remove anything else that's unnecessary. If you're running a web server and you have other mail services or some other applications running on there, there really shouldn't be for best security practices because those are other avenues for a server to be exposed to any kind of attack at all. Web application firewall, if you're not familiar with what these are, they're awesome, first of all. This is more of a device or service that's intended to scan the traffic as it's reaching your server, so that it can see if any kind of malicious users, malicious traffic is making it into your server. SQL injection. Anybody here know what SQL injection is? So SQL, simply put, it's going to be preventing people from being able to send unauthorized data to your server and perform a malicious action to either acquire your data, expose parts of your application for further, what's the best term I'm looking for here? Just for more or less further exposure of your customers' data and your data altogether. The web application firewall's main purpose is to inspect the traffic, make sure that it's healthy, make sure it's normal traffic, make sure it's expected traffic, customers browsing the site, looking for purchasing a product, browsing different catalogs. That's all it should really be. That's going to help protect that. Vulnerability scanning, internal and external. We're talking here more of a service where they're going to be able to scan the servers to see if there's any exploits available in the code, whether they're common or not. Internal and external, it's either the scope is faced from inside your environment or from the outside coming in. You can get different results either way, but it's worth being able to see if there's any weakness in your code that you need to be aware of. Offsite backup and encryption, I talked a little bit more about your data at rest. If you're performing backups, and as far as I know HIPAA and PCI will require you to have that data secured and encrypted off-site for your backups. That's one of the big things here, where you're shipping it off-site to a different location, and it's going to be encrypted on the way so that data is protected at rest. Dual-factor authentication, we're diving a little bit more into how people are accessing the environment from an administrative level. So your staff, yourself, anybody who's actually going to be accessing any secure elements of your site. Dual-factor authentication is adding in a second step. For example, if I'm trying to connect to my network here with dual-factor authentication, I actually have to have my phone pull up a code that's on my phone as well as type in my password, and that code rotates on my phone. So I'm seeing a different code each time I try to log in to ensure that not only is it something that I know, my password, it's something that I have, my phone with the token code on it. That's your dual-factor. There's even triple-factor authentication in some different ways. You think of biometric, if you're trying to access a secure area where you need your thumbprint and a badge. Well, it's something you have, and then something you are, you, biometrically. Even a PIN, add 3 factors to that, even to get in our data centers. That's actually a good point. In order to get into our data centers, I need to swipe my thumb, swipe my badge, swipe my thumb, use a PIN in order to access that data center. 3 forms of authentication. Now, how easy is it for somebody to get, well, I'll just make it more than my thumb. I guess that's kind of, somebody can get my thumb. Knowing the PIN that only I know, a little more difficult. Getting my badge, which is in my bag, I keep thinking it's here, that's probably the easiest thing versus my thumb. I mean, I've seen some people that can get a thumb. I'm just saying, I don't want to go into too much detail there. But having 2 factors is a great thing to have because it's not only something you know, it's something you have. Or something you are if you're using biometrics, but typically you're not using biometrics, say, for connectivity. And then the last thing is log inspection and analysis. So FIM and SIM is where we're looking at is file integrity monitoring is FIM, where you're actually have a service, an agent running on your server that's watching all the important files to see if anything changes. If there's a program on there that's required for your application, and that changes unexpectedly, FIM will catch that. If a user, or a malicious user specifically, is able to modify or inject any kind of content on your site, and and FIM's going to check that and see that, hey, this file it changed this day. Is this normal behavior? It'll be a flag thrown up. SIM is more of a log collection, where it's looking through and gathering all like your system events to see what's going on in your system, log them into a central place so that in the event of any kind of breach and you need to go back, that's where SIM's really going to come in. You're going to be able to go back and see, well, what happened around this time? Can we trace down when this breach was? How far in did this person get? That's really where the SIM and FIM kind of fall in. It's more post-mortem, I guess. Everything's sounding horrible when I say it. It's like post-mortem to a breach is really where those things are going to shine. And then there's always the fun topic of disaster recovery. This is your insurance against something going wrong. High availability has its up and down side because you're also usually gaining performance with high availability, but you're able to distribute traffic. Disaster recovery is truly an insurance policy. So what I want to talk about here is what defines a disaster. That's up to you as a business owner, as any kind of involvement with the company to define when a disaster has occurred. Is it as simple as the website's been unavailable for 1 hour, we need to execute a disaster recovery plan where we have another application elsewhere that we're going to run? Or is it our data center has just fallen into a black hole? It's going to be 10 hours until we have anything online and we need to come up with a plan. And it also brings in questions as far as what's a recovery time objective? How long can we be down? What is the total time that it can take from we declare a disaster to being back online? And then recovery point is, at the point we declare a disaster, how far back can we afford to lose as far as data? A lot of people want to say this is zero. If we have a disaster, we don't want to lose anything, and we want to be up instantly. The closer these numbers get to zero, is a lot more money that gets put into that kind of plan. And that's something you really have to think about as a business owner, as someone who's making these kind of business decisions, is what can we afford to really find as a good ratio. And even, like I mentioned before, with what I do with INetU, I'm working with a lot of our customers, and this is one of the most important things here is this entire page comes up anytime I talk about any kind of disaster recovery. I want to know what's in scope, what needs to be protected against disaster. What is the recovery point? What's the recovery time? And what defines that disaster? How are we going to really define the scope of this situation and find a solution that fits? Now, like I said, the closer these get to zero, the more it's going to cost overall because you're working with more advanced technologies, more advanced solutions that need to be near real time in order to accomplish it. But there's also some simpler options too. So say we're running this awesome enterprise model, right? We had my Beanie Babies are selling great. We got this going. And the giant anvil falls out of the sky and just destroys the data center. Well, wish I had a DR plan. Wish I had some kind of recovery method for this. Well, it could start as small as having your data shipped off-site in backup form. I have a USB drive in my office that has every single piece of data I need to restore server. Great. What's the recovery point on that? Well, I take it once a week, so a 1 week recovery point at the most. Oh, well, how long does it take you to get on the server? Well, I gotta buy a server. I gotta get it plugged in. I gotta get it shipped out. You know, I might just go with the AWS thing and then just send it over the wire. What do you have? I have a 56K modem. It'll be fine. You know, it's only 20 terabytes. It'd be good. Well, that recovery point may be a week, but your recovery time it's starting to really increase by what your needs and what you can afford at the time. Maybe all you can afford is that USB drive. But will that be able to save your business? And that's a really important thing. If you lost all your data today, if everything just disappeared, is your business okay? Would you be able to bounce back from that? A lot of people say no, and it scares people. And I'm not trying to scare anybody here, but at least having some form of recovery, some kind of backup off-site would really help in that situation. And especially in the case of a giant anvil falling on your business. So, let's say I built that little small cloud environment over in the West Coast. And the East Coast, over in New York City, I have this environment running. Over in Seattle, I have this environment running. What's the purpose here? Well, what I'm doing actually is I'm behind the scenes here, sending all my web data, my website content, all those details over to this server. So it's keeping a copy of it. And the database is doing the same. Every time it's running a transaction or any kind of change, it's being shipped across the wire over here. Let's say my recovery point is about an hour, roughly. We'll say this synchronizes every hour. This is nearly real time. And my recovery time to go to this environment, if you're familiar with DNS and making a simple DNS change, that could be instant. Oh well, the change itself could be instant. By the time it propagates, maybe an hour. So I'm looking at a 1 hour RTO here, with just a very simple cloud environment out there, running all the time, hanging out, cost of a firewall and 2 servers. It's a really big step from a USB drive connected at home. But it could be a lot more helpful, a lot quicker recovery.
Do you recommend active always?
No, I only recommend active when we're talking dedicated links.
Alright.
In this case, this is more of, we have like an active passive cluster here, and it's going to be shipping data, simple log shipping or replication across the wire. I wouldn't recommend having it be active because you're probably going to cut some corners in your DR as far as performance. Like I may have dedicated gear all the way over here. I may only need some cloud servers over here to sync.
Active standby, you're saying?
Sort of, yeah. Where this could be kind of hanging out and taking over traffic briefly while I try to rebuild my production environment. Which is another good question is your DR environment meant to take over production traffic? Or is it meant to rebuild production? So there's so many questions that really come in. And DR is important, but I think it's more important to just look at your business saying, what do I need to do to sustain a large-scale failure? You may not need a cloud server. You may not need 2 of these in 2 different locations. But you need something. I definitely, even if it's like I mentioned that USB drive, I'm going to be mentioning it all night now. I'm going to walk around with a flash drive and be like, you got your USB drives, guys? Because you're going to need it. In the event of anything, you want to have yourself covered. CYA. That's really what that is. That's what DR realistically is. So now we've gotten through some of the good, the bad, the ugly there. We'll just talk about hardware and software briefly. And by hardware roles, I want to really talk more about the CPU, memory, and of course the disk performance and capacity in an environment to really determine how this is going to make your Magento environment perform, or any e-commerce environment in this case. So, processing power. Traditionally, your CPU utilization is really going to take place mostly on the app server. Your application is going to be your CPU consuming resource. The database server will as well, but not as much. And most things that I've seen, your application is doing a lot of the heavy lifting. Maybe more so once you have some more optimized caching. It's important to know the expected workload of your application. If you're designing an application to have a lot of rendering, a lot of activity going on, you want to be able to build resources behind that to account for that. You don't want to have it under spec and perform poorly. Cloud has the cost advantage here because you can get very simple resources, very basic container, and then grow that as you need. This is meeting our needs today, we'll leave it be. Well, the site's starting to get slow, we've got a lot more products and more customers, we're going to need to grow. That's where cloud really shows the advantage. Physical, however, usually has the advantage because these are dedicated resources. You're getting 100% consumption on, there's no virtualization involved, no overhead, so you're going to get a little bit more out of it there. But the downside of that's going to be cost because you need to plan. If you're buying physical hardware, you need to know when that hardware is not going to be enough, or how much at least you need day one. Cloud, you can just, okay, we're going to spin up another server, or we're going to grow this instance vertically. There's options there. I'm going to add 2 more CPUs to this. Excellent. This server, I'm going to add 2 more CPUs to this. Well, I better wait for the UPS guy to show up from Dell. That's going to be about a week, and that just cost me $2,800 in resources. No, this cost me $5 a month to upgrade? Okay. Like, there's really a lot of different opinion here, but scaling is a lot better on cloud. Start small, go big. Physical, if you know where you're going to be, you'll get those dedicated resources. And of course, caching. Caching is my other favorite word. I'm going to walk around with a coffee mug that says caching on it and a thumb drive. That's going to be my reminders for the rest of the day. That's going to alleviate a lot of the workload on this tier by caching those results, whether it's a full page cache or different opcode caches. Memory capacity specifically here, it fluctuates. It really does. It's not going to be a set number of, you're doing e-commerce, you need 5 gigs of RAM. Okay, what are you doing? Okay, you're selling a different product, so let's say 6 gigs of RAM. It's not like that. It's more of what your application, what your users are doing, how many users you're getting. If you have 10,000 people browsing your site and you're using a minimal amount of memory for your application, maybe more in the database and the caching tiers, but if you're able to actually look at that information, you can get a better idea of when you're going to reach a certain point that 200,000 users, well, if we get 200,000 users, our server's going to crash. Well, you don't want to have that. You want to have a good idea of what the future's going to bring. Caching layers will really rely on the memory tier most of all, because you're storing as much information there as you can in a fast, readable access method. Database tuning, it's going to be helpful here to keep your memory where it needs to be. You're going to more or less tune your database to use your memory so that you're not accessing the disk. And my font's a little messed up here, but avoid reading from disk whenever possible is the best advice I can give in any kind of high-performance application. Store as much as you can in memory, get it out of memory. That way you're not relying on slow disk speeds or any kind of poor disk performance, which brings up disk speeds capacity. So capacity is straightforward. I need a certain amount of storage. Here's how much storage I need. I'm buying that much storage. Done. But when we start talking about like actual spindle seek times, IOP performance, things get a little bit different because not a lot of people dig into this realm. If you're looking at like solid state drives, they're accessing that data as quick as they possibly can off of flash memory. And that's really where you want to be. You want to be able to pull that data as quick as you can if you have to go to disk. Rely on your caching layer. That'll definitely help out here. On the app tier, disk performance is usually hit or miss depending on what your application is doing. If your application relies on accessing data from disk very often, not relying on the database, not relying on cache, but actually pulling directly from disk, you're going to feel some pain there. But it's really the database tier and any kind of caching that takes place is where you're really going to save your disk performance and how that's going to play in overall. Capacity is cheap, but flash is worth it. That's my end statement here on this page. We want to understand that you can buy terabytes of storage. You can buy, I think, like 2 terabyte drive now for like $80. That's a hell of a lot of storage. That's compared to years ago. But flash storage, when you start looking at that kind of a price, you can buy like 60 gigs of SSD for $80 right now. I don't know if that's right. Don't quote me on that. Anybody run a hardware store? They sell computer parts? Awesome. Okay, nobody can quote me wrong. So we'll consider that fact then. But think about it. You're paying for performance, not for capacity. Or on the other side, you're paying for capacity, not for performance. Web tier, the application tier, you may not need the performance. The DB tier, that's really where that's going to shine. If you have a separate caching tier, that's going to shine there as well if you're relying on disk, which we'll kind of talk about a little bit more for your caching. But here's that drawing that we had before. We talked about it a little bit. Well, let's shift it over and kind of talk about each tier and really where we're talking about the big consumers. So, there we go. Caching. That front page, that full page cache we talked about before, that first place we're going to hit, that's pretty much going to be your memory concern there. You want to make sure you have enough memory to support that tier. Your application is pretty much going to be your CPU consumer, your processing power. Once again, memory, we're back to caching, your opcode cache, any of the PHP APC caching, we're talking maybe memcached here in the same aspect. That's where your memory is really going to lie in, where you want to have some fast in-memory operations. Database is a little bit more towards the disk, but also memory, but it's pretty much your big disk consumer because you're storing a lot of records. You may not be able to store everything in memory, depending on how many SKUs you have in your database. So let's look at that in the scope of, we'll assume that we haven't tuned well for anything that's recently accessed, but there is going to be stuff accessed from disk. We'd probably be looking for a higher performance disk tier here. So on some of these quick database topics, one of the questions that always comes up for your databases for Magento is Percona versus Oracle MySQL, Java, whatever they're doing nowadays, who knows. So out of the box, Percona does provide better performance day one. But with tuning on both of those services, you can get very close to the same amount of performance, but this requires time to get to tuning. If I were to recommend something today, saying, I just want to plug something in and make it work, Percona, I would recommend Percona. If you don't know the history of Percona and MySQL, Percona was a fork in the code years back, I think 4 years now, maybe more, actually I think it's more than that, but it was a fork in the code, and it went in a different direction. The company took the code in a different direction, and day one is still out of the box a higher performing database, whereas MySQL continued its development in a different direction. It doesn't perform as well out of the box, but can be tuned just as well because we're talking still a lot of the same code underneath the hood. So realistically, I say either option is great. If you have a staff that you really want to optimize things, I would say MySQL. If you don't have a staff that's going to be able to do these kind of things, Percona out of the box. Even if you do have a staff, Percona is great too. You have to do a little bit of research to see if anything fits your needs or doesn't fit your needs, but that's my recommendation there. Maintenance operations in general, cleaning up the database. What's that mean? Well, there's some log tables that typically come in with Magento that need to be cleaned up periodically. Being able to clean up those will at least speed up your database because now you're not caching or storing things in memory that aren't really that important, and you can kind of trim things up overall for better disk performance. And periodic tuning review too. So we talked about tuning up here. Really seeing what your server is doing, how it's optimized, and adjusting that is something I would highly recommend doing quarterly, please? At least quarterly, guys? No? Okay. Maybe yearly? No? Okay. Well, those are usually the answers I get. How often do you tune? Well, what year is it? Okay, so you haven't tuned in a while, got it. But it's a question worth asking because your workload may have changed and you need to make sure that your server's running to meet those kind of needs. Whether it's hosted or not, if you have somebody like a cloud service provider that manages everything, have them take a look and see if everything's performing well. If you run it in-house, Hopefully you got somebody in house, because that's great. If not, who wants to learn? Time to learn. Last thing on the database I really want to talk about is external operations. And I have seen a lot of pain from whether it's an external application, some kind of job that you run as part of your application, but it's outside your typical application stack. We had a customer of undisclosed name using a payment vendor of undisclosed name to basically keep track of their inventory in physical shops and reflect that on their Magento storefront. The problem here was that they couldn't use full page caching because it was a restriction by the plugin. Big problem there. The second problem that they had was it was constantly writing data to the database. If anything went on in its system, like if it was just somebody did a read on a row, it's like, oh, there was activity here, resync that data. Okay, we're gonna sync this data, and it just kept sending information from stores all the way up. If somebody scanned a barcode, somebody added something to inventory, somebody purchased something, they would send all of the data from that entire store up into Magento. And one of the big concerns here is locking the tables. When you're writing data to a database, it's going to prevent multiple things from writing that same data at the same time. It's going to perform a lock. I call this data in first. I'm putting my data in first. I'm first in line. This guy's going to have to wait until I've written my data. Okay, now I'm done. You can go. If we had a situation where somebody was about to make a purchase or something like that, this data came in and it's like, hold on, I'm sending you all my information from my store. Catch all this information. No, customer, you can wait. Here comes more information. That's going to cause a bit of a problem. Back to that, click a page. All right, it's been 10 minutes. Should I give it another minute? Let's just click it again and see if it comes down. You don't want people waiting around for your back-end processes to run. So that's something I would keep an eye on, is how you're managing your database and using it. And backups. Always have backups, whether they're on-site, off-site, a USB drive in your office. Have some kind of backup of your data because you're always going to need that. Now this is going to be one of the final things I talk about, is cache backends. I know
I have a small, not at all.
Am I running low on time?
But everybody just grab a bite while.
Oh, okay, yeah,
It's much
absolutely.
easier for everybody.
Absolutely.
Okay, get started with. Alright.
Alright, so we're talking caching.
Pass it down, sorry.
We mentioned a couple things before: opcode cache, full-page caching. Well, as far as Magento is concerned, there's a couple different layers. First one is the file system cache. This has what's considered the cache tag support, where it's able to use a certain key value store that Magento is very familiar with. It's more or less relying on disk to store any kind of cache information, whether it's specific records. If you've done any development with Magento, you can see that a lot of information can be stored in cache for quick access. Pre-processed, nobody needs to do any work. Thanks. The file system is still going to be your slowest form of cache because you're still writing to a disk. Now, if you build a system to have like SSD drives, you have these solid-state drives that boom, they fly, it's great. You're still writing to those disks. You're still reading every single one of those pieces of information every time you're wanting to purge cache. So it's not really the best, but it works out of the box. It's there, day one, you can use it. You're relying on your disk performance, but it is better than nothing because you're not reprocessing every single computation that needs to take place on your app tier. Go on, there we go. APC, which is a form of PHP caching. We're talking back to now fast in-memory operations, where you have a service running that's using your memory to store all these computations that are taking place, whether they're specific transactions, any kind of rendering, anything that would fall into the PHP opcode caching. These kind of cached here. So you're taking some strain off of your web application if you're using PHP. In this case, APC will take any of that operational standpoint, take a little bit of it back. If it's already run this certain calculation, a certain function, it'll keep the results. Installation, well, it's simple as installing a package if you're running a popular distribution. And if you're not, and you're a big do-it-yourselfer, you can have a lot of fun setting it up. A little extra work. Does require tuning out of the box, in my opinion. The opinion of the internet is just install it, it works, it's great. But if you really want to use it to its full potential, you need to really tune around that. There's no cache tag support. Now, as far as the cache tag support, there's only two things that really have it. The one was the file system cache, and then we'll cover another topic later. But this is going to make your caching a little bit more optimized as far as purging it and keeping it maintained. And we're still relying on the file system here for anything that's not considered opcode cache. Anything that APC doesn't cache, well, you're back at your file system for that kind of portion of it. Then there's memcache, which is another fast in memory, runs as a daemon. Can be accessed either locally or through TCP, so you can actually offload Memcache to a different host. You can have a Memcache server from multiple web servers. And in this case, though, there is still no tag support. We're relying on the file system that anything that doesn't fall within this object cache. So we're talking key value cache here, and you're still going to have that reliance on the file system if you're not fully leveraging it. But then, Redis. Now Redis here, still, fast in-memory operations, runs as a daemon, can be accessed local or TCP. So far, we've hit everything that Memcache can do. But this does have the cache tag support that Magento is looking to use to make things optimized. Installation is a bit more complicated to get the Redis working, because it's not something that was really, you can install it right away, but there's a lot of configuration that needs to take place as far as on the Magento side to use it. So it's a little bit more of an advanced topic. Community Magento can actually use it for full-page caching, whereas Enterprise has its own full-page cache built in. This can be your full-page cache layer. And now we've arrived. We got something that does the cache tagging. We have all the positives that we needed in order to arrive at a simple conclusion of full-page cache, object cache. So let's look at it kind of as a little diagram here. So Redis is kind of doing its own thing. It's handling all the caching on this side, whether it's full-page or not. Whereas over here, our file system's kind of overlaid with Memcache and APC. They're not quite overlaid with each other, but anything that Memcache isn't handling, the file system will handle. Anything that APC is not handling, the file system will handle. So if these guys aren't handling all your caching needs, the file system's still going to be relied on. Whereas with Redis, with this cache tag support, you don't need to rely on that operating system, the operating system and the file system. It's providing that complete solution, including the full-page cache, which we keep talking about as the first line of defense against slow page times. There's no need for the file system to cache at all. APC can still be used, as well as Memcache, to layer on top of it. I would actually picture Redis being more in front here if you're trying to do any other optimizations to your opcode or anything specific to Memcache and APC. You can gain any efficiencies there. You can use them together. It's more complex to implement, but, I forget what that whole slide says. Well, it is more complex to implement, but it is going to present you with a more complete solution. And they don't pay me or anything, so don't just ignore that check. They don't pay me to talk about Redis. So, full-page cache, topic we've talked about a few times. Well, it's included with Magento Enterprise. They have their own full-page cache, FPC suite built into it. Many options are available for the Community Edition. Some are considered more hackish, but we just talked about Redis. Redis is a great fit there. Our customers that are using Community Edition usually rely on Varnish and Turpentine, as well as Redis. Separately, they would usually pair these two together and Redis by itself. But that's what our customers are using today. A lot of what we've done more recently is kind of discovered what works best. Talk to customers, because a lot of the time when they come in development-wise, they already know what they're doing. We're coming in, we're using these technologies, and we want you to help us achieve that. Hey, Jim, you looked at this. No, we're doing this. Okay. This is what we would recommend, but we'll help you get your solution that you need, make recommendations along the way. And that's typically where we get this split between Varnish and Redis. We're looking at simplicity and elegance of using a Magento Enterprise in this case. There's simplicity and elegance of buying Magento Enterprise, the support, everything that comes with it. But then there's cost. We're putting that against cost. Like, it's not cheap product. So it's worth looking at other avenues to see what is community supported, such as Redis. And Magento doesn't pay me to tell you guys to buy Magento Enterprise either, I'm just saying. So we're back to the question, which is best? It still depends, but I'm going to help you guys break this down a little bit. You need to know your needs, as far as how you want to build your e-commerce application. Like performance needs. Do you need your site to run at maximum performance all the time? Are you concerned about any kind of downtime associated with additional users accessing your site? Business needs in general. Like, are we going to be moving to Magento? Are we going to move to any other storefront? You need to know these things ahead of time and really come up with a plan, find the pros and cons. Even working with people like Janine and I in our company, we can really discuss what solutions seem to fit within all these options. We'd be able to help you out there. Manpower. Having the people to do the work that needs to be done is a very simple term. But in this kind of a sense, we're looking at designing an environment, having developers, having people to be able to support your storefront as well. And that also comes in with experience. Make sure people are well trained and actually know what they're doing. Not just having hands hitting keys, but making sure they're well trained is really important. Because you don't want to have, so I'm not a very good developer. I don't know if I opened with that yet. I'm a pretty crummy developer overall. Like, I'm great with systems. Development, not that great. You don't want me hammering around on your systems. That's, well, developing at least. I'll fix anything that's broken. But I'm not gonna, you don't want me developing. So you want people with that kind of expertise, not just somebody, not going just down the street here and saying, hey dog, you know Magento? All right, let's Magento, come on. You want to make sure your people are experienced in trading. And the last one, and probably more importantly, is budget. Budget is a big thing. You need to know what you're coming into as far as a budget to determine what costs you can actually absorb to move to either a new web space, new development costs. All these kind of things are really going to play in, determine what you can afford and what kind of a solution you can build. If you're looking for a small start, you might be able to get away with that with pretty low costs. But if you're looking to maybe expand what you're having today, things might be a little bit more costly, and you need to worry about your design there.
Brian?
Yes.
Sorry. Oh, okay.
Yes.
You caught me.
That's pretty much where I want to wrap up
warning
here.
for Q&A.
Yep, that's exactly where I'm at.
Okay.
So, as far as questions, is there any at this point right now? Do you want to have any discussions? You guys want to talk about anything? I know I just talked at you for a long time, and you're probably tired of me already, but I'm willing to talk some more.
This guy, I'd like to thank him for coming from Pennsylvania. They came all the way, Janine and Brian came a long time to talk to us today. So, if you guys have any questions,
Where do we get your home brew?
He's ready to answer them.
I have a question.
Yes.
Okay, so you talk about the infrastructure support like Magento framework. How about like other solutions like WordPress or PrestaShop? Do they have different requirements in terms of infrastructure support?
Well, there'll always be slight differences as far as how the application is developed and specific to the provider. If we're comparing Magento or any other application out there, they're all going to have their own requirements. A lot of what I covered here is kind of the core infrastructure needs. Things to really concern yourself with: quick load speed. You want cache. You want to have something, no matter what you're using, you want to have some kind of quick cache in front. No matter what kind of a solution you go with, you want to look at having more memory available for that cache. So that infrastructure design is pretty much universal. It's more of the practices in general. I know a lot of it was specific towards the Magento stack. That was actually just a good way to example any application that you're working with, an application in a database. You have a web tier, you want to speed things up as much as you can. So a lot of it's going to be finding pain points, finding slow portions of the application, figuring out how to speed that up either with like a caching method, either code optimization is always a thing, but it's not always the end-all be-all solution. You want to be able to have some right infrastructure under it, and all these will apply to almost any solution.
Thank you. Give her a mug.
Yeah, you get a mug for that. That was a good question. Everybody got some mug down?
I like that.
You get a mug. Oh, the hand went up with that one, Steve.
What's the difference between your service and AWS? What's the difference? It's like the same service, like, or it's cheaper than
It's
AWS?
different. There are definitely differences. So,
Is it cheaper than AWS?
in some ways, no. In some ways, yes. We're working on a little bit of a different operational model than AWS. A lot of our costs really come into the support side of it, or that whole white glove service that we provide for management, any kind of requests that come in, things like that will really be where we shine out over AWS. It really doesn't have much of a support offering today. Their infrastructure is a little bit more different too, as we have our own cloud resources, which is a VMware-based cloud with EMC storage backing it. So we have a highly available in the physical layer cloud. Whereas we're looking more commodity cloud over with AWS. It is usually cheaper, like pound for pound, but you also have to get into more of that AWS mentality of designing your application to not be your conventional server model where you want to be deploying applications, not servers. There's a really a big division there. You want to leverage their services in your applications, not have a Linux server that I run these application servers on. No, you want to have, this is my app server, this is my database tier. All these items are going to be separated out on AWS to really achieve that kind of efficiency and cost savings. Otherwise, you're just buying some kind of hosting elsewhere. Now, granted, as far as the raw infrastructure costs, yes, AWS is cheaper than what we offer, absolutely. But our cost really comes in with the support side of things.
So you're just like a commoditized offering. You're essentially like an actual service.
Well, yeah, we are a managed service provider.
Exactly.
That's what we do. Whether it's cloud, our own cloud, we even do managed services on AWS. So if you have AWS, we can bring that in under our umbrella and provide support there, and physical, and even the private cloud, like I mentioned before. Like the options I mentioned before, infrastructure is all things that we work with every day. Oh, we got more questions. We need a mug for that, sir. Actually, I think I owe you a mug too. You asked the question in the presentation. They're really nice mugs.
I'm not really the best potential customer.
How about a battery pack?
I'll take the mug. I took a little coffee.
Yeah. Did you have one? Anybody?
Yeah, I did.
Okay.
Let's say, Brian, right?
Yes.
So let's say I open a Magento store, right? 5,000 SKUs, I install everything that I need. I book, I do business grows. Business grows from 5,000 SKUs to, let's say, 70,000 SKUs. And I have an import in certain processes installed on Magento. Database logs. How do I deal with them? Do I look in the database? Do I bring out, add additional resources to that? And a lot of developers say, well, Magento just has database logs all the time. It's just like a matter of creating a system. Basically, what would you say in regards to that?
In that specific case, so being able to account for what your growth really is and how much data you really need to retain. The first thing is, how much of the data do you still need day to day? Is there any kind of operation to kind of truncate something like the log data is one thing I always say. Either don't say just delete it, say, oh, let's go on, throw it out. Even if you dump that information off or you have it backed up and retained for a certain period of time, truncate what you don't need. Absolutely. You want to keep things running as lean as possible. As far as database logs, it all depends on really what you're doing in the application. Connection pooling is a very powerful thing in MySQL specifically. It's a little more of an advanced topic, but you're opening connections to the database and you're using that pool of connections for just quick establishment. So it's going to prevent locking as far as connectivity is concerned. When you're actually doing access, it's only really locking on writes. So you got to be aware of where your writes are taking place. And if you're doing any kind of bulk import operation, you should want to do that outside your business hours. So that's definitely a recommendation so that you don't during the middle of the day. Yeah. During the night, whenever your traffic, and if you're monitoring these kind of this data, how often users are hitting your site, when, you'll have that data already to say, this is when we should be doing this, so we're not going to get hit as often, or things like that.
This is exactly what I get from my developers from all over. They say, listen, these are all, depending on how on your usage of the site, all these memory sessions and user session, they're all stacked up. So you better do your imports during the off hours.
You absolutely want to retune. You want to see if your resources meet there. So even on the MySQL side, there's a lot of tuning that you can do configuration-wise to meet what your connections are, how many connections you have available. Even if it's the point where you're exceeding your connections, you don't have enough memory to establish all these connections for all these storefronts. First of all, awesome, because you got a lot of people hitting your site.
Yeah.
Second of all, crap, I need to get more resources because I'm hitting a cap at some point. You got to know when the cap is, and that's when you really got to be aware of what your system's doing day to day. And as far as table locking, you want to watch how often you're writing data. Even if you don't need to write data, don't.
You don't do it exactly.
Yeah, avoid it.
It's a style import, so the customers often we want to upload the style as often as possible. We want to have styles constantly coming in, let's say once a day, and importing that import takes, let's say, someone from 8 to 12 hours to process. So clearly, sometimes it blocks the database.
And even a big help there would be kind of optimizing that process too. Taking that window, tightening it up. Even if it's a business requirement that I should be able to run this whenever. I should be able to stop my site functioning whenever I want. We'll say it like that. You need to find the best way to reduce that as much as possible. Would be my recommendation.
Yeah.
If it's going to happen during lunch when everybody's shopping for food, like Domino's website at lunch, we're going to have a 5-minute outage at some point during the lunch hour. Can we make that 2 minutes? Maybe 1. Like that's really what the angle that you're looking at that from.
Thanks.
You're welcome.
We'll take one more question for the group, and then you're welcome to come and,
Come on, I got 2 more batteries.
stay with Brian.
Oh!
Based on your information, you say, you monitor your Magento site 24 times 7 times 365 days. And you have all the engineers jump and fix the problem. How did you do that?
Well, we have a monitoring system. That's an easier question than the Magento question. So I actually came from our client services team, I mentioned before. What we have is a monitoring system where, on the web tier, we're monitoring the website to see that it's available. If at any time we see an alert, there's 2 things that we have happen. Say, there was a power outage of some kind. It's rare if that ever happens, but we'll just say there was a power outage of some kind, your website went down because of it. Our monitoring system is going to pick up that that website's not responding anymore. And within about 5 minutes of that moment of that happening, there's a light going off in our actual client services. A siren, not a siren, more of a chirp, I guess you would describe it as, and a light, a orange utility light, letting everybody know that something's down right now we need to look at. At that point, you're also getting emails from a monitoring system saying, a certain fault was encountered, here's an email letting you know what just happened, and then we'll be reaching out to say, hey, we've encountered this alert, we're looking at it right now, you know, we'll check to make sure that you're not doing anything that we're interfering with if you're providing like you're deploying a new piece of code. Well, we don't want to go in there and just willy-nilly restart a server because, oh, you're deploying code. We don't want to do that. We want to actually look at the problem and see what it is, and that's where all of our teams come in. They're 24/7, so whenever that light's going off, somebody's looking at that issue, and that's what that whole 24-hour incident, somebody's jumping on that issue, is literally true. Like somebody's standing up going, who's working on the light right now? You're working on the light, great, let me know when that's done. I'll call the customer while you're fixing it. And that's how we really coordinate those kind of alerts to achieve pretty much what's printed there.
How do you do the 24-hour people? Is it like shifts in PA, or do you have like a Kuala Lumpur team, or?
PA, everybody shifts in PA.
All right, that's awesome. So they all know each other. No, but it's cool when they know each other and they actually work together versus like a KL spot or a Singapore spot, or when you try to just distribute across the time zones. At least all your people are working together, know each other, know the.
Yeah, on our engineering side, we do have
awesome.
like I think 2 people that just one that telecommutes, right? Grillo? Yeah, we have one person who's actually working up in Massachusetts. Who's been with the company. Oh my God, how is he? Chris is.
Two other, there's another one.
Oh, is there someone else? Oh, okay. Well, we have Chris who's been with the company for longer than I have by, like, take how long I've been there? I've been there 6 years. He's been there 15 years. He's been there a long time, and it's somebody that we never really wanted to lose when he went to move away. So he actually telecommutes out of. He's not. I want to say Boston.
A little bit north of Boston.
A little bit north of Boston, Seattle. That's a little far off.
So am I.
So we do have people that aren't on site, but it's literally somebody that used to be my boss, so I know him very well. He's a fun guy to work with.
What's the biggest frustration with Magento?
The biggest frustration is really coming up is being able to present a design that we feel would make improvements, but our customers usually aren't ready to make any changes. Whether it's implementing a layer of cache, or following any kind of best practice that's not really within their business model to make that change, that's usually our biggest pain point. Example of like somebody not using a full page cache, they didn't want to spend the time to look into using a full page cache, or even, is this still here? I started putting together a bit of a case study. It's going to be awful to read, so I kind of talk about it a little bit. A lot of problem was they're having slow page times when they came to us, but they really weren't able to engage in any changes at the time. So what we ended up doing was working with them, making recommendations, and to the point where they actually started looking to do it on their own. Where we made recommendations so many times that they decided, well, maybe we should be looking at these recommendations. Maybe we should be implementing these caching layers. And that was the biggest pain point we usually have across the board is we can make recommendations as much as we want, but somebody's usually coming to us with a product, and they don't want to change that just yet. Or they're in a situation where they paid for the site as is. They paid a developer, I got this site, but I want to move it, I want to make it better, I don't have the money, I don't have the time, I don't have the expertise, all those kind of things that fell on the list. That's usually where it comes from, is there's a lack of ability to change in the immediate future, where we may have to adjust the infrastructure design around what their solution is today to make it work. So it's a bit painful that way because we're kind of doing it backwards. Like we want to show you this is the best way to do it. But if we can't do that, it's like, well, here's how we make the best out of what we got. You know, it's still a good way of coming up with a solution. Not best practice, it may not even be the best cost-effective wise too. But it's usually the hesitance to change that really hurts us.
He gets better, pass so shaped.
Yeah.
Oh yeah. Pass that down.
I just need
Hope
it.
you got more goodies. There's more questions.
Oh no, I have one more month. Yes.
We have another one.
Right.
To implement a business model called concept, would you recommend to launch the ERP software on cloud or on data center basis?
It's
To integrate it with Magento.
realistically, you want to. Depends on the workload, in my eyes. So you're looking at shared resources typically when you're on any kind of cloud service, whether even our cloud, there is a sharing of resources, but it's a little bit more limited. Yeah, it's all about the workload. I would look at analyzing where you need your highest performance tier to be. Is it the CPU, the disk, the memory, and finding the best solution that fits in there. Like if it's CPU and memory that you're really constrained upon, you can pretty much get away with cloud. I found that disk is actually one of the hardest, the biggest bottlenecks you'll come across on shared resources is being able to access your disk efficiently, because it may be on an array or some kind of a storage device that's shared across many people accessing it, slowing it down. So if it's heavily disk reliant, I would try to steer clear of the cloud if possible. But cloud's actually a great place to even to test it, to get your dev environment up and online on a small cloud server. It'll be a little bit more cost effective, like a single CPU, 2 gigs of RAM, enough to get it to run. All right, so we have it purring. Let's make it roar. What can we do to really make our application run? Where are the bottlenecks? And you can use almost like a step-by-step analysis of, all right, it looks like right now, the way this is running, we're short on CPU power. We're not really getting as many transactions complete as we need to. Let's up that resource. Oh, okay, that's running great, but we're running out of memory when we spin off so many processes. So let's get you'll find the happy medium that way with the cloud. You get that scalable benefit. And I don't want to frown upon the cloud. I know it always sounds like I'm saying, oh, don't go with the cloud. The cloud, no. Cloud's still a good option for a more budget solution where you want to be a little bit more dynamic and agile. But if you're looking for raw performance, raw horsepower, that's when really physical hardware comes in. Where you want to be able to use all those resources that you purchase. That's more where that comes in. But I wouldn't shy away from the cloud. I would actually try it out on the cloud first, and then decide if you want to use dedicated gear after that.
And what size of the business would you recommend to encourage them to look for Magento enterprise?
Oh, enterprise. I don't know if it's a size. It's more the business need here, where if you need the leverage to make Magento support, that's one of the big reasons why you'd be looking more towards a Magento enterprise. If you need their support to help out, like maybe you don't have all the staff that you need to really accomplish a complete solution, you would be looking at leveraging them a lot more. And I would leverage the snot out of them if you're using them for support, because that's what they're there for. It's what you're paying for. You're paying all that money for it. And their caching is something else that kind of comes with it, that full page cache that's integrated in. It's a lot more of a seamless technology, but you're still paying for it. I don't know if a business size, it's going to be more crunching numbers. It's going to be budget and business needs at that point. Do you need to leverage their support? Back to actually that one slide I just had here. Like, performance really doesn't play in here. It does a little bit with the full page cache, but we'll say you're using the community edition with your own full page cache. It's about the business needs. Do you need the support? Do you have the manpower and the experience to handle everything you need to handle day to day? No? It might be worth looking into. How does it fall in the budget? Being a really big question because it's not free. So it's hard to give an answer to that. I could definitely say it's worth looking into and seeing what your need as a business, if it's worth going for the support through Magento. But size-wise, that's a really hard number to put it on because I don't think anybody ever needs to go to enterprise. I think it would be the easiest. There's no absolute reason, like I've reached this point and that's the cutoff point. Hello, enterprise, here we go. No, it's what you need out of enterprise. What's enterprise doing for you more than anything?
You can always get the side markers.
Yeah, you could. If the community's very active, there's a lot of things out there. You don't necessarily need to pay for the full enterprise edition, but if you can make use of those features, then it becomes a little bit more worth it. Get some bugs.
We run out of door prizes?
I think
we ran out of door
Are we done now?
Okay.
That was a way to get some questions though.